Okay, and so we'll be talking about your activity 10, your physical properties and general tests for your carbohydrates. Okay, and so let's take a look at your physical properties of your carbohydrates. And so accordingly, and so all your monosaccharides and your disaccharides are white crystalline substances. Okay, and so you have here your glucose, your fructose, your sucrose. And so accordingly, based on that, all your monosaccharides and disaccharides are white crystalline substances. Your starch are amorphous powder. And so you have it as your amorphous powder, while your most complex cellulose is fibrous. Okay, and so you have here let's take a look at your cellulose, your cotton. And so you have your cotton as fibrous. And so your glycogen, that is white and smooth. Your starch, accordingly, that is creamy white and smooth. Accordingly, amorphous powder. Your lactose is white and smooth. Your sucrose, white and granular. Your crystalline. Your light yellow for your ribose, that is powdery also. Your fructose and glucose white, and they are powdery and granular respectively. Okay, and so that is for your physical appearance and texture of your carbohydrates. Okay, so let's take a look at your solubility of your carbohydrates. Okay, and so accordingly, your solubility of your carbohydrates is inversely proportional to the complexity of the structure. Okay, and so if you have an increasing carbon atoms present in the chain in your what they call this in your carbohydrate, then the solubility is decreased. Okay, and so solubility in water is decreased. Okay, and so your carbohydrates are soluble to your polar solvents, and they are insoluble to your non-polar solvents like your ether. And so for this, and so it applies your like dissolves like. Okay, and so your sugar dissolves in water because accordingly the energy is given off when the slightly polar sucrose molecules form your intermolecular bonds with the polar water molecules. Okay, and so your solubility of your solvents, you have here your monosaccharides and disaccharides are soluble in water. Your starch, they form colloidal solution with your water, and then they are somewhat slightly soluble, no? And so they form colloidal solution. But then when you boil, and so when you increase the temperature of your solvent here, and so your starch will uh, be dissolved completely accordingly. And then your cellulose here is insoluble to your general solvents. Like you have there your water, insoluble to water, insoluble to your ether, and other general solvents in also insoluble into your alcohol. Okay, and so you have there for your solubility of your carbohydrates. Okay, so you have your Anthone test. And so this one is a general test for your carbohydrates. And so for this, it uses actually a condensation method. Either, and so the products of your hydrolysis are combined with other compounds. Okay, and so for this, it uses your reagent, Anthone reagent, and your concentrated sulfuric acid. And so for that, your sulfuric acid will hydrolyze your carbohydrate if you have your disaccharide, oligosaccharide in the solution, then it will hydrolyze it into your component monosaccharide. And then your sulfuric acid will also dehydrate your monosaccharide to produce your furfural derivatives or your, ayan, so for your furfural, that is for your pentoses. And so furfural is produced when you have a pentose sugar and your hydroxy furfural for your hexose. Ayan, so for your pentose, a furfural is produced. For your hexose, a hydroxy furfural or hydroxy methyl furfural is produced. Okay, and then of course, these furfural derivatives will interact with your anthrone to produce a blue to green color. Okay, and so it will interact with your anthrone to produce a blue to green or blue green color. Okay, and so that is for your anthrone test. Okay, and so you have here your Molish test. your Molish test, again, this one is a general test for your carbohydrates. Okay, and so for this, and so again, it uses your condensation method. Okay, and so let's take a look at the reagents used in your Molish test. You have your 10% alpha naphthol in ethyl alcohol and concentrated sulfuric acid. And so your sulfuric acid here will dehydrate your sugar to produce furfural derivatives of your aldehyde. Okay, and so to produce furfural derivatives of your aldehyde. Again, you have for your pentoses, you have it will yield your what you call this furfural, and then for your hexoses, it will produce your hydroxyfurfural or your hydroxymethyl furfural. And this one, of course, it is not specific for your carbohydrates. Okay, and so for that, again, your sulfuric acid will dehydrate your sugar to produce furfural derivatives. And then these furfural derivatives will what you call this combine with your alpha naphthol to produce a violet ring. And so it will combine with your alpha naphthol to produce a violet ring at the junction of your two liquids. Okay, and so your positive result for this is a production of violet ring at the junction of your two liquids. Okay, and so this one is a general test for your carbohydrates, and so theoretically, all of your carbohydrates will test positive for this test. Okay, so you have your iodine test. The iodine test here, and so this one is also known as your potassium iodide test. Okay, and so let's take a look at your reagents used here. And so you have your Lugol's iodine as the reagent, of course. And so you have your iodine forms a large for this, and so it use your Lugol's iodine, sorry. And so it's a combination of your potassium iodide and iodine in water. And so that is your Lugol's iodine. You have your potassium iodide and iodine in water. And so for this, and so your iodine forms a large polysaccharide complex with your alpha amylose helix to produce a blue-black colored complex. Okay, and so your alpha amylose here, this one is a component of your starch. Okay, and so your starch contain alpha amylose, a helical saccharide polymer, and your amylopectin. Okay, and so your starch, they have your amylose and your amylopectin for this. Okay, and so you have here again, and so your iodine forms a large polysaccharide complex with your alpha amylose helix to produce a blue-black colored complex. Okay, and so let's take a look at your results for this. And so your starch will give a blue-black or probably indigo for this. And then your glycogen will give a red color, and then your dextrine will give you purple. Okay, and so this test will distinguish your starch from other carbohydrates. Okay, and so it will distinguish your starch from other carbohydrates. Your disaccharides and your monosaccharides will give a negative results for this. Okay, at your starch and your glycogen. Okay, and so your starch granule is made up of amylose. And so 98% of your starch granule is made up of amylose. And so this one is the linear structure, and then amylopectin, which consists of highly branched chain. Okay, and so you have here your amylose and your amylopectin here. And so your starch, and so it has your amylose and your amylopectin, your amylose being linear and unbranched, and your amylopectin being long, branched, and coiled accordingly. And so in your amylose molecule, and so there are about 300 glucose units in its unbranched chains with a molecular weight of 50,000 accordingly. And so in your amylose molecules, and so you have here 300 glucose units in unbranched chain with a molecular weight of 50,000. And so you have a molecular weight of 50,000. Okay, and so your amylopectin that is present in your starch and so appears to contain in its molecule several branched glucose chains. And so again, as what we said earlier, it is branch consisting of about 25 to 30 glucose units in each chain. Ayan, so consisting again, constituting of about 25 to 30 glucose units in each each chain. Okay, and so that is for your amylose and your amylopectin. And then you have here your glycogen. Okay, and so your glycogen, and so or your also called as your animal starch, and so has a branch structure, has your this one, your glycogen has a branch structure with straight units. Okay, and so with straight units of 11 to 18 units. Okay, and so again, your glycogen that is short, many branch chains, some are coiled, and they are made up of your alpha glucose. Okay, alpha D glucose. Okay, and so you have here for this one, you have the presence of your alpha 1 for glycosidic linkage and your alpha 1,6 glycosidic linkage. Accordingly, and so the molecular weight of your glycogen ranges from 270,000 and so to 100 million. Okay, and so it has what you call this a molecular weight that ranges from 270,000 to 100 million. Okay, and so you have therefore your ayan, so both your starch and glycogen, they are made up of your alpha D glucose. And so they are made up of your alpha D glucose. Okay? Okay, and so let's take a look at your glycosidic linkage. And so your glycosidic linkage, and so that is made up of your condensation or dehydration reaction. Okay, and so the residual and so your OH group of your hydroxyl group of a monosaccharide combines with your H of another sugar to release water, creating a covalent bond. That is actually your formation of your uh, glycosidic linkage. And so your glycosidic linkage is a type of your covalent bond. Okay, and so in your sucrose, and so you have here your in your sucrose you have there the uh binding of your one glucose and one fructose molecules for this. Okay, and so in your sucrose, and so your OH group on the anomeric carbon of your alpha D glucose in the OH group of the anomeric carbon of your beta D fructose combines. And so giving you your alpha 1 accordingly, alpha 1 beta 2 glycosidic linkage for this. And so let's take a look at your amylose, your amylopectin, your glycogen again. Okay, and so your amylose, and so you have here your linear. And so for your amylose, you have your linear glucose units. And so for that, you have your alpha 1 4 glycosidic bonds present in your amylose and in your amylopectin. And so this one, it has a linear form and branch. Okay, and so the branching, and so you have, it carries your, what you call this, alpha 1 4 present in your amylose because you have it as linear. And then the branching is at your 1 at your sixth carbon position. And so giving you your bond, glycosidic bond present here in your amylopectin is you have your alpha 1 4 and your alpha 1 6 glycosidic bonds. And so while in your amylopectin, you only have alpha 1 4 glycosidic bonds. And so for your glycogen, and so it is branch, there is linear, and there is branching also. And so for that, you also have your alpha 1 4 glycosidic bonds and your alpha 1 6 glycosidic bonds. And so the attachment is your at for your alpha 1 4, you have it at at first carbon and the first carbon of another of a glucose and at fourth carbon of another glucose. And then for your branching, and so at first carbon, sixth carbon, sorry, and so at sixth carbon of your another one glucose and at first carbon of another glucose. And so this one is your sixth and this one is your first carbon atom. And so for that, alpha, meaning both of them are made up of alpha glucose. And so this one's your what you call this, your amylose, your amylopectin, your glycogen, they are made up of your alpha D. And so alpha glucose. Okay? Okay, and so let's take a look at your cellulose. And so your cellulose, and so it has a molecular formula of C6H10O5. And so this one is the most abundant organic compound, making up 50% or more of your carbon vegetation. Okay, and so for this, and so this one is made up of your what you call this linear carbohydrate, sorry, linear glucose and no branching. And so linear and no branching for this. There is no branching in your cellulose. And so the attachment of your glucose units are at your 1, 4. And so at the first carbon and your fourth carbon position. But this time, the glucose is in beta configuration. And so the glucose present in your cellulose is in beta configuration. And so for that, giving you a beta 1,4 glycosidic bonds in your cellulose. And so again, you have your beta 1,4 glycosidic linkage in your cellulose, given that your cellulose is made up of your beta glucose or beta D glucose. Okay?